So I'm going to do the even problems for you as one like kind of final summary so that you can do the review and then finish up factoring. We'll probably do some more after break too. Okay, so first type of factoring is when it just says factor out the greatest common factor. And so we're looking at the biggest number that goes into all three terms. And you can always do this. So I look at 10, 20, 50, and 80. I know that 10 goes into all of those. And so I know that 20 is 10 times 2, and 50 is 10 times 5. So I know they don't have that common factor, so it's just going to be 10. And then I take the highest power that's in all of them. So it ends up being the lowest power there, so just 10x. And that leaves me with 2x to the third plus 5x plus 8. So what I'm doing is dividing each of those terms by 10x. Okay, for the second one, and this is stuff we did before we started e-learning. For the second one, 45, I know that's 5 times 9, which is 3 and 3, but I'm going to leave it like that. 9 is, I'm going to write as 9 times 1 because I know they have that same common factor. And 18 is 9 times 2. So all three of them have a 9. So my biggest factor is 9. And then I'm looking for the power that's in all of them. There's an n and an m. All of them have an n. And this has a 4, 4, and a 5. So 4 is the biggest factor. There's no m in the other two terms, so that is not a common factor. So that leaves me with negative 5. The n's gone. Minus 1. Well, the end of the fours cancel out, leaves me with m squared. And then minus 2. And n to the fifth divided by n to the fourth is just n. And you can always multiply back out to get back to your answer. The last one's a little more complicated because it has 4 terms. But looking at the numbers, 5 is prime. So I just got to make sure, does 5 go into all of them? If it does, I should be good. So 5. And then there's an A and a B, an A and a B, and an A and a B. So the power of A that's in all of them at least is A to the fourth. It's hard to read, sorry. And the power of B that's all in is just plain old B. So 5a to the fourth B. So when I go to divide, I get negative 4. A to the fourth goes away. B to the 8th divided by B is B to the 7th. Minus 3. A to the fourth cancels out. B to the 4th divided by B is B to the 3rd. And then 15 divided by 5 is 3. A to the fourth cancel out. B and B cancel out. So that's just factoring great common factors. Nothing else I can do with it. Go to the second kind. And I put a hint here. It says factor completely. The key is that there's 4 terms. And so you're going to use grouping to factor this. That means you're going to group the first 2 and the second 2 and take the GCF out of each. So the biggest number that goes into 5 or 35 and 40 is 5. Leaves me with r squared also goes out of there. So I have 8r plus 7. And if there's a negative on this second one, I know I can take a negative out. The biggest number that goes in there is 2, and that gives me 8r plus 7. So I took out a negative 2. Whoops. Those have to be the same. We write like this: 5r squared plus 2 times 8r plus 7. Same here. I'm grouping the first and second. Biggest number that goes in both of those is 5. M squared is the biggest power. That leaves me with 8m minus 3. And so I know I need to end up with that over here too. See, I know 4 goes into both. 12 does not go into 32, so it's just 4. 8m minus 3. And these are the same factors. So 5m squared plus 4, 8m minus 3. So 4 terms, use grouping. So when you do this, you're going to group these two. There's a whole video on that too. You can go back and watch if you need. This one, factor completely, it says hint, difference of 2 squares. That means as long as you're subtracting and each is a perfect square, you can write it as pairs of factors with taking the square root. So the square root of 4x squared is 2x, and the square root of 5 is 5. So the difference of 2 squares is always 2x minus 5, 2x plus 5, or the other way around. This is the one most of you did well on the quiz. You just have to be careful to watch out if there's any pluses. If there's a plus, you can't factor it. So are these a difference? There's a minus, and both of these are perfect squares, so I write my perfect squares. 5x, 5x, 1 times 1 is 1, go minus and plus. Same thing here. I have a difference. They're both perfect squares. So I have 3a and 3a, 5 and 5. Just to be different, I did plus first there. It doesn't matter, as long as these signs are opposite. So those are all pretty straightforward rule-oriented ones. And then we get to the new stuff, probably the most important factoring that you're going to use in your other math classes is factoring trinomials. So the key here on all of these in this section is that the leading coefficient on the squared term is a 1. So I know I'm going to have R and R, P and P, K and K, X and X, because I'm forcing that to happen because that's the only way I can get R squared is R times R. And then I'm looking for numbers to put in to see if they multiply to give me 10 and they add up to negative 11. Well, 1 times 10, that's 10, and they add up to a positive 11. So I could go negative 1 times negative 10, and that would give me negative 11. So negative 1, negative 10. And the other way, if you watch my other factoring video, I like to write those little brackets down there. And the reason that is true is if you multiply this back out, you get R squared minus 10R, and that's negative R plus 10. And so that's your R squared minus 11R plus 10. But when R is 1, or when the coefficient's 1, you can kind of shortcut it in there. Okay, so the next one is 12. I need to think of things that multiply to give me 12 that I could get a difference of 1. So 4 and 3, 6 and 2. So I'm going to use 4 and 3 because I know I can get a difference of 1 out of that. And I want it to be a negative 1. So I'm going to put the negative with my 4. So that's a negative 4p, and that's a plus 3p. Negative 4 plus 3 is negative 1. Be careful and always check, because you can pick things. You can put 6 and 2 in there and they would give you the 12, but they're not going to give you the negative 1. The last one, or the second to last one here, I have 60. I'm going to do 6 and 10. There's like 3 and 20. There's a whole bunch of them here. 60 and 1, 5 and 12. But I know with 6 and 10, I can come up with 16. 6 plus 10 is 16. So plus 6 plus 10. Those two numbers multiply to give me 60 and add up to 16. So there's not as much guess and check here because you don't have to switch the first term around. So for 20, I have 5 and 4, 2 and 10, 20 and 1, can I come up with 8 somehow with one of those? Well, 10 and 2 can give me 8. I want it to be a positive 10 and a negative 2, and that will work because that's a negative 20. So positive 10, negative 2, and those are factored. So this is a really important page, these last 2 pages. So as we get to here, now I don't have numbers that are as easy, but I know 7 is prime. So I know when I'm guessing and checking, I have to have 7x and x. And then I'm going to guess and check 4 and 1 and 2 and 2. I'm going to start out with 4 and 1. I put them in there. That's 4x, and that is 7x. Using 4 and 7, I need to come up with negative 3. Well, that's possible if this is negative 7 and positive 4. So I want the negative here and the positive here. Now, I just happen to guess the right one. It's like I've done this before. If I would have said, let's say I did this and I put the 1 here and the 4 here. Well, that's 28x and 1x, and I can't come up with that. So then it's called guess and check because you got to just switch them around. Or let's say I started out with 2 and 2. Well, that's 2x, and that one is 14x. 2 and 14 cannot come up with 3. So that's why the only one that works is when 4 is here and 1 is here. Okay, 9x squared. Now 9x squared is a little tricky because it can't just use 9 and 1, but we're going to start with that. Normally, I would probably start with 3 and 3, but I'm just going to start with 9 and 1. 32 is also tricky because there's a whole bunch of 4 times 8, 16 times 2. I'm almost always going to start with the one that's most in the middle. So I put a 4 and an 8. So I get 72 and 4. Well, 72 and 4 definitely can't come up with 12. So I'm not going to change the 9x. I'm going to change where I had the 8 and the 4. So I'm going to put the 8 here and the 4 here. So that's 8x and 36. 36 and 8 still can't come up with 12. So at this point, I could try 16 and 2, but I'm skeptical because 16 is pretty big. So I'm erasing and starting over, and I'm going to use 3x and 3x. So I'm going to try my 8 and 4 again. And that's 12x and 24x. Well, I can come up with 12 using those two. And it needs to be a negative 12. So I want negative 24 and positive 12. Whatever put the little brackets on here. That means the positive has to go here and the negative has to go here. So that one is a little more of a process. Before you finalize your answer, if you want to check, you just check by multiplying. You can do this or you can use the table. That's 9x squared minus 24x plus 12x minus 32. Negative 24 plus 12 is negative 12. So that is the same as what we started with. Okay? So you're going to go back and do the odds, and then you can check the answers to see how you're doing, and then there'll be a short quiz.